Let's talk about creating a vector class and what a vector class needs. So vectors need, one, to keep track of their current size. This is how many elements are currently in the vector. In addition to that, we also need to keep track of the capacity. This is how many elements the vector can currently store without needing to be resized, the underlying data. In addition to that, it's also going to need a reference or pointer to the block of memory, right? This is just called like a data pointer in some way. The fundamental class of a vector, I believe, just has these three things, right? So when you go to create your vector class, it might look something even as simple as this. Public, granted this is C++ syntax. Vector, or class vector, public, we're going to have our vector constructor as well as a vector deconstructor within our class. We'll probably have a pushback function. We will have a resize, a reserve, and a few others. And then as part of the private data within our vector, we'll have an integer representing the size, how much data is currently in the vector. We'll have an integer that represents the capacity, how much space this vector can store. And then finally, we'll have some sort of pointer to a block of data, right? Now, if this vector works with just integers, this is going to be an integer pointer, right? We just call that data. If our vector is templated, this would be our template data at some point, right? Or if it's just a vector of strings, this would be a string. If it's a vector of characters, this would be a character, whatever type of data this is. So now let's talk about some of the initial functions. Let's talk about initialization. During initialization, we'd expect to see a few things, right? So here's the vector constructor. Within our vector constructor, I'd expect to see a few things. The first one is we want to set the size equal to 0. There's nothing in this vector yet. Let's clear it out. We want to initialize everything about this vector class. The next thing, we want to set our initial capacity to something. Well, how much space should a vector initially be able to store? 2 elements, 10 elements, 100 elements? I'm not sure. This decision's entirely up to you. I'll just go with 10. And then finally, we need to initialize our data, right? If we need to be able to store 10 elements before we resize, then we need to initialize this data. And we're going to do that using the new operator. So we do something like this. Data is equal to a new, now I'm just using integers here, a new block of integers, which is the size of the capacity, right? One thing to note here is whenever your capacity changes, you must be changing the size of your data that you have in memory. And conversely, whenever the size of your data changes, you must be changing the value of your capacity. I would always expect 2 lines of code to be very close together like this, where the capacity is changing, it means your data is changing. Your data is changing, it means your capacity is changing. Right? In a nutshell, this is what I would expect inside the constructor of your vector. Let's talk about the destructor. Now, remember when we are using pointers, and especially when we're using this new operator, we always have to delete our memory. Otherwise, we end up with a memory leak. The size is not a pointer. We don't have to do anything with that. The capacity is not a pointer. We don't have to do anything with that. Our data, however, this is a pointer. We have to make sure to delete this when the vector class is destroyed. Our code that should exist right here should be something along the lines of this. I want to delete this block of data, right? One special case thing that I will note. If your vector is in turn holding on to pointers of data, you would need to loop through your data and delete each element, followed by deleting the data itself. If your data is just a fundamental type like this, just a block of integers or something else on those lines, then this is good enough just to delete the block of integers that you've allocated.